Hello, my name is Ankish Priet. Today I will be discussing my senior project. The main objective of my senior project is to create a robotic lawnmower capable of autonomous features as well as user joystick control. This is the frame that we fabricated to start this project with. This is made with steel tubing that we welded and fabricated up. In the front we have a caster wheel. In the back we house two wheelchair motors taken off from an old wheelchair that we had laying around. There will be a coupling system to connect the wheelchair motors to the back wheels, which are pneumatic tires. The lawnmower itself is sitting on 4 pegs, so what we can do is actually take out these pins, which are coming from like tow truck hinges, and we're able to take them out and adjust the height according to whatever the user specifies. This design gives us a great feasibility in adding a lot of external products to it, such as like a fail-safe system, any other motors that we might need for this project. The back of here, give you a little tour around. Back of here we'll house 2 car batteries to power the electric portion of this lawnmower. This will be able... There was great consideration taken into what the types of electronics we need to make this operational. It's important to note that when a lawnmower is mowing down a field, you need to have a certain type of accuracy so that the lawnmower itself does not go over a certain area more than once or completely misses it. So we decided to use something called an RTK-based GPS, which uses 2 GPS units to communicate with each other. One will be connected to the actual rover itself, which is our lawnmower in this case, and then one will be as a base station. The base station communicates with the satellites, as well as the rover station part communicates with satellites, and then those 2 communicate with each other, providing correction data. Instead, with the current GPS models available that we can use, you are typically seeing 1 to 2 meters of accuracy with your position. With an RTK-based GPS, we are able to get precision up to 2 centimeters, which is more than enough accuracy for the lawnmower to use. So what we got going on here, this is a Pixos controller. It is from a typical drones, hobbyist drones, quadcopters and the likes. And what it does is it houses an internal accelerometer and magnometer to give you your heading and orientation. Also built inside is the GPS unit that we will be utilizing for this. This comes from U-Blocks, which is a company based out of Switzerland that makes a lot of good high-profile electronic components that can be used for Arduino or even commercial applications. So with this combined system, what we're able to do is attach extra peripherals to it. So here we have a step-down voltage converter to power this guy, which will be powered with our 3-cell 2200 milliamp LiPo battery. And then another peripheral that we have is a PPM receiver connection, which we're using a hobbyist grade receiver that you typically find from RC planes or drones that communicates with a transmitter. With this functionality, communicating to our autopilot system, we're able to allow the user to switch between the autopilot and manual joystick controls using the levers here. And it's just a matter of flipping on and off a switch to switch between the 2 functions. Now, in order to power the wheelchair motors themselves, we needed a motor controller that can handle the current that we're running, that the motors that need. Since we are hoping to be able to do like extreme terrain and a lot of inclination, there will be a lot of current draw through the batteries to the motors. We needed a motor driver to do that, to handle the capacity. So here we bought a Sabertooth 32 amp driver, and this is a 2-channel driver to control both of our motors. And the way that we have this guy configured is basically like a tank. So you have each wheel spinning independently. So if both wheels start spinning forward, the entire lawnmower will go forward. If they start spinning the opposite direction, you'll get 0-point turning, depending on the input that's given by either the autopilot system or by the user itself with this joystick control. So to test this out, we need a small scale robot to kind of simulate what our design is. So here we just bought a hobbyist Arduino simple robot. It originally had 4 motors controlling each wheel. So we took 2 of the motors off, and so only the back ones are driven. And this simulates what we have going on with the lawnmower itself. With this testing, we were able to conduct a lot of trial and error coding, trying to get the accuracy pinpointed to where we want it. And we can also start testing waypoint to waypoint movement. This software here is called Precision Mule, and this is how we can generate waypoint data for a selected area of field that we want to have mode that our autopilot feature will focus on. So I have San Jose State in the map shown. And what I can do is create a boundary area of a particular field that I want to have selected. So after I do that, I go ahead and click Build Mission according to the specs that I have here, and then it actually creates data points for the location of each of these dots that you see. After that, we can save the waypoint file to a text, and it generates all the information that we can use to read for the autopilot feature. Now, this is Q ground control. This is the waypoint software that controls the Pixox autopilot feature. And what I'll do here is connect the Pixox to my laptop. And after that, it'll start calibrating the compass and the GPS module. And soon you'll be able to see that it will find a GPS lock for the current location that it's at. And here we have my position located. In the upper right hand corner, you can see data of the orientation of the Pixox itself. So as I move the Pixox up, you can see that it goes up at a certain degree. You can move it down. And then the compass, as I tilt the device side to side, you can see it change where the direction of it relative to north. Using all these parameters, we can upload the text file of the waypoint data to this software, and we can actually begin to tell the autonomous lawnmower what to do. Another demonstration I'd like to show you is the radio feature. As soon as I turn on the radio, you can see it start calibrating. So now it's reading the signal from my transmitter to the receiver module connected to the Pixox controller. And this is how we can use the RC functionality. So we have, as I'm moving the stick, you can see each channel reading a certain value, depending on the position orientated on the controller, and as well as another switch that we can change from autopilot to RC. The next important topic to discuss is the impact. What's the significance of our project? So every year, 6,400 people die or are injured because of lawnmower-related incidences. With our system, since it can be remotely operated, there's no need for a user to actually control the device directly with their bodies. It can be all done using computers or radio control. Now, the other impact that we have is that this pushes towards an all-electric world. So as soon as we begin to understand how the autonomous feature works, we can also think about what if we used an all-electric lawnmower for the base of this project. That way, instead of using combustible fuel and harming the environment more than it needs to be, we can push towards more of a renewable energy resource to recharge said device, and it would be have a great impact on the environment. For the next steps that to finish the fabrication of our project, we need to think about a coupling device between the lawnmower wheels and the electric motors themselves. Also, a housing to place all the electronics in. And we are still working on the wireless internet communication between the laptop and the autopilot system, and also the correct fail-safe procedure so to ensure the safety of the user. For version 2 of this project, for future iterations, we would like to be able to use a smartphone to control our lawnmower. Also using ROS, which is a robotics operating system, plus the camera, we can implement machine learning algorithms so that when we place a camera in front of the lawnmower itself, we can actually track what's going on, and we can start implementing obstacle avoidance per se. So it'll recognize a fence, a tree, a human, and it'll avoid that or stop in position. And then just in case that the water is or the ground is wet and it's raining outside, we want to have a waterproof housing for the electronics using probably plastic frames. And then think about also making a lighter frame for the base, probably using aluminum. And then also switch out the gas-powered engine with an electric lawnmower. So this concludes the project that my team and I have been working on for the past year. This is the autonomous lawnmower project. My name is Ankish Priet. Thank you for viewing this video.